Hello friends, as discussed in the earlier video lecture, the solution for the draw tool and the steps involved in it. Today we are going to see a complete solution for a draw tool problem. Now the problem statement is we have to draw a cup type of a shape, and the statement has given design a draw tool for the cup as shown in figure. Given data is the material is ms, thickness 1 mm, and the yield strength is 450 Newton per mm square. Now in the problem, if we see the shape which is we required to draw from the sheet metal is having the height as 110 and the shell diameter as 70 mm, and the radius for the cup is required to be 1.2 mm. Now the first step as calculation of the blank diameter. This step can be carried out with the formula the blank diameter d is equal to square root of d square plus 4dh, where this d, small d, is the shell diameter. We are knowing the shell diameter is 70 mm. By keeping the value of small d and h, we can have the blank diameter as under square 70 square plus 4 into 70 into height 110. So the blank diameter in this case becomes 188.94 mm. Now in this step only we have to add the trimming allowance. The trimming allowance is added so that we can easily get the cup out from the die, and the additional, we can say, the cup we can get cut, or whatever the diameter we are increasing, the height we are going to increasing with the help of this blank diameter, additional blank diameter. So that trim operation we require to be carried out thereafter, and for that purpose the thumb rule says that for every 25 mm of the shell diameter, you have to add the trimming allowance of 3.2 mm. Now here, the 70 is our shell diameter. So for 25, if the value of trimming allowance is 3.2, then for 70, what will be the value? So this cross multiplication we can have for this, and we can get the value of the trimming allowance as 70 into 3.2 divided by 25, which is equal to 8.96 mm. So we should add this trimming allowance into the blank diameter, and the new blank diameter in this case becomes the blank diameter 188.94 plus 8.96, which is 197.9, which is approximately, we can say that 198 mm we should consider. So 198 mm blank diameter we have to take initially, the sheet we have to take initially, so that we can draw the cup with the 70 mm shell diameter and 110 mm of the height. Step number 2 is getting the draw ratio, so that we can get the value of how many draw operations will be required. And for that purpose, the draw ratio, which is given as h by d ratio, so h by d in this case it is 110 divided by 70, that is 1.57. As the value of this draw ratio is more than 1, so we can say that the draw operation is critical and it will be required the number of steps. So as earlier video, I have given one table, and from that table we can get, if the h by d ratio is 1.57, then from the table we can say that 3 draw operations will be required to complete the operation. So at least 3 dies will be required, 3 punches will be required, so that we can complete this operation. So step by step in the 3 operation we have to go. The next step is the overall percentage reduction, so that we can get the 3 draws, and for each draw what will be the percentage reduction we should carry out. And in this case, the overall percentage reduction, if we go for directly from the blank diameter to the shell diameter, so the overall percentage reduction by formula, it is blank diameter minus shell diameter divided by blank diameter into 100. So this value becomes 64.64%. As the value is more than 50%, so we can again say that the operation is critical and we have to see the permissible limits for the drawing. As in earlier video it was been given that the permissible limits are in the range of first 45%, then 30% as like. So we have to consider the first operation if it is correct for 45%. So the first reduction if we made by 45%, so in that case, so new blank diameter becomes earlier blank diameter 198 minus 45% reduction of 198. So value of the blank diameter comes 108.9 after reducing it by 45%. So if this reduction if we apply directly, 45% reduction if we apply, so in that case the next reduction should be minimum than 30. But in this case the percentage reduction comes as 108.9 minus 70 divided by 108, that is blank diameter minus shell diameter divided by blank diameter into 100. So it comes to 35%. So in the permissible limits, so after 45% the next value is 30%. So your value should become 30% or less than that. But in this case the value is more than this means that the initial draw operation by 45% it is not suitable in this case. So we should think about the next probability for getting the reductions, and for that purpose the next reduction probability, and for that purpose the next we can say the operation we have made as the first reduction if we consider by 30%. So by 30% the blank diameter in this case will be 198 minus 30% of 198, that is 138.6 mm. And considering this new blank diameter, if we go for the percentage reduction as the blank diameter minus shell diameter divided by blank diameter, so the value it comes to the 49.49%. So we can say the value comes below 50%. That means the first reduction if we go with the 30%, so the value comes below 50. That means this can be possible. So the second reduction if we again make by 30% of the reduction, so in that case the value again from the 138 which is the earlier blank diameter, if we reduce again 30%, so 138.6 minus reduction of 30% again, that is 0.3 into 138.6. So the next value becomes, next blank diameter becomes 97.02 mm. So considering this new blank diameter, if we go for the percentage reduction, so the value is 97.02 minus 70 divided by 97.02 into 100, that is blank diameter minus shell diameter divided by blank diameter. So this value comes as 27.85, which is less than 30%. So we can consider the first reduction as 30%, second reduction as again 30%, and the third reduction as 27.85%. So with these three steps we can carry out the drawing operation. Then it will be possible that we can draw the height of 110 and the shell diameter of 70 mm from the selected 198 mm blank diameter. So this is probably a good solution that we can reduce the blank diameter as 30% in first reduction, second reduction 30%, and the third reduction as 27.85%. If we consider the earlier 45% reduction, then it may be possible in that case that the cracks can be developed and the drawing operation will not be the perfect, because the second draw reduction will be in that case will be 35%. So we cannot apply the 35% in the second reduction. So it may be quite difficult to go with the first probability. So second probability is good and we can start our operation in this sequence only. Now the step number 4 is to draw the stage-wise drawing if our percentage reduction stage is complete. So by considering that percentage reduction, we have to draw the stage-wise drawing. So stage 1 is we have to consider the blank of 198 mm size. Then the first reduction we have made by 30%, and in the 30% we have to draw a curve, okay, and for that curve the blank size is known to us, that is 138.6 diameter. By 30% reduction we are knowing this value, but this height value is not known to us, so we require to calculate over here. And for that purpose again the same formula we have to apply, that the blank diameter is equal to square root of d square plus 4dh. Now in this case, the 198 is the earlier blank diameter which we are reducing by 30%, and in that case the new blank diameter, that is shell diameter, whatever we achieved is 138.6. So by keeping that value, that is 138.6 square plus 4 into 138.6 and the unknown value of h. So h is unknown over here. So if we solve this so we can get the value of the h, and the value of the h in this case becomes 36.06 mm. So you have to write the value over here, that is this value is in the first reduction comes as 36.06 mm. Now in the third step again we require to draw by 30% reduction, and in this case the new, we can say, the blank diameter which is known to us, by reducing the earlier 138.6 by again 30%, the new blank diameter comes here as, or the shell diameter comes as 97.02 mm, and the height will be unknown. In this case we require to again apply the same formulae over here, and we have to calculate the h2. What will be the h2 in this case? So h2 will be in this case that blank diameter. In this case again we require to consider as 198, because the earlier blank diameter is same 198 mm, and we have reduced it to the d, small d, and in this case the d becomes 97.02. So considering this value we have to calculate the h value. So h2 will get over here, and in the third reduction we have gone for 27.85% reduction, okay, so that we can achieve the last step, that is the shell diameter becomes 70 mm and the height becomes 110, or it will be more in this case because we have added the trimming allowance which we require to cut thereafter. So this way you have to draw with respect to a center line, you have to draw the three curves, and in the three steps we have reduced the component, okay, so that we can get the final component as like we have to show in the stage-wise drawing. Now after completion of the stage-wise drawing, we should move for the next step, that is size of the punch and the die. Now in this case we should always know that the draw operation, in which size of the punch, it will be provided with the clearance, and the clearance is of the twice the thickness. So in the first reduction the curve size which is there we got is 138.6. After reducing the blank of 198 we are reducing it to 138.6. So the punch size in this case is 138.6 minus 2t, that is the clearance provided on the punch. So this value becomes 136.6 mm. So that we can say this punch, if we provide, so we can get the value inside the die for the shell, it is 138.6. Size of the die in this case, it will be provided with the plus clearance, so that the cup will be get inside, and we can have the die clearance as, or the size of the die in this case becomes 138.6, that is the cup size plus 2c, and the 2c value for the die, it will be provided with the formula as 2.20 of the thickness. So 2c value is 2.20 of the thickness, or c value, as earlier said in the video, the c value is 1.t of the thickness, that means 2c becomes 2.20 of the thickness. So thickness in this case is provided as 1 mm, so the 2c value for this die becomes 2.20 into 1 mm thickness, that is 2.20 mm. So the final size of the die becomes in the first reduction as 138.6 plus 2.20, that is 140.80 mm. So the first reduction operation, it will be provided with the die size of this diameter and the punch size of this diameter. Now in the second reduction, the size of the punch, as the size of the cup in the second reduction is 97.02 minus the 2t, that is the clearance provided on the punch, 2t. So the value becomes 95.02 mm, and the size of the die in this case, so 97.02 is the cup size in the second reduction plus 2.20 of T, that is thickness is 1 mm, that's why directly I have written here 2.20. So we can have 99.22 mm as the size of the die for the second reduction. So this will be becomes the second die and second punch which will be required, so that we can reduce the cup up to 95.02 mm, or we can say 97.02 mm in this case. The third reduction we can have for, and in that case size of the punch becomes the exact size which will be required, so that is 70. So 70 minus 2T, that is the clearance on the punch. So the size of the punch in this case becomes 68 mm, and size of the die will be 70 plus 2.20 mm, so 72.20 mm will be the size of the die. So this way you have to write the how many reductions will be required. So for that reductions you have to calculate the size of the punch and the size of the die with the formulas, that for the size of the punch, so cup size in that draw minus 2T, it becomes size of the punch, and size of the die as the cup size plus 2.20 of the thickness. Okay, so according to that you have to go for this step. Then the next step is to provide the corner radius for the punch and the die. So as earlier said, the cup requires the drawing operation, and in that case the sheet should not be get ruptured, and for that purpose we require to provide the corner radii on the die and the punch, and for that purpose the formulae or the thumb rules are being provided. And for the corner, for the first draw, the corner radius on the punch, it will be provided as 4T. So here thickness is 1 mm, so 4 into 1, that is 4 mm we require to provide the corner radius on the punch. Corner radius on the die we can take from 6 to 10 of the thickness. In this case I have taken 6 into thickness, so that is 6 mm. So you can assume any value from 6 to 10 over here. In the second draw, again I have taken the punch corner radius for the punch as 4 into thickness 4 mm, and corner radii on the die I have taken 4T, so it becomes in the case 4 mm. In the third draw, the corner radius on the punch should be 1.2 mm, because we require to have the 1.2 mm as an inner side radius for the cup which we require to be drawn. So the final value on the cup, that is already given in the numerical, that is 1.2 mm corner radius it is been required, and that should be given on the punch, and the corner radius on the die, so we require to have the 4 mm. So this way you have to provide the corner radius on the punch and the die in this step. The next step is to calculate the draw force, blank holding force, and provide the press capacity required to complete the operation. So the drawing force in this case, as given by the formula FD, drawing force FD, it is pi into D into thickness. D is the shell diameter, so pi into D into thickness into sigma yield into D by D minus C. The capital D is blank diameter and small d is in the shell diameter, and minus C, that this C is the constant whose values we require to take as 0.6 or 0.7 or in between that. So in this case the blank diameter is 198 mm, small d, that is shell diameter, is 70 mm, thickness is provided 1 mm, and C value we can take from 0.06 to 0.7. In this case we have assumed it 0.6, and sigma yield value is given 450 Newton per mm square. So we have converted it as 450 by 9.81, so that we can have the value in kg per mm square. Now the value, if we put these all values into the formula of FD, we will get the final drawing force as 3.14 into 70 into 1 into 45.87 into 198 by 70 minus 0.6. So by keeping this value we get the drawing force as 22,468.96 kg. That means 22.46 ton capacity will be required for the drawing operation. But again, only the draw operation, the drawing force is not important. The blank holding force is also required, which will be again provided by the press, and whose value is 1/3 of the draw force. So by thumb rule it was been considered that 1/3 of the the draw force, and 1/3 of 22,468.96, it is the value becomes 7,489.65 kg. So by adding this blank holding force and the draw force, we can get the press capacity, and in this case the press capacity becomes 29,958.61 after addition of FD plus FB. So we can say that approximate 30-ton capacity machine will be required so that this operation can be completed. Thank you.